All right, good morning and welcome. I'm back as promised. We will now do a numerical on photoelectric effect. And this will give you a glimpse of how do you approach it. So this question is from JEE mains and 2016. So I'll just explain you the situation and then we will try to solve this. So this is on photoelectric effect and JEE mains 2016. All right, so you have this metal, and the metal is struck by a photon which has a wavelength of lambda 0. Okay, and it is observed that the kinetic energy of the electron which is emitted is, for example, it is given to be KE1. Okay, so the emission has taken place, which means whatever frequency is available to you, the threshold frequency was there. So you had the minimum work function which was taken care of. Now, for the same metal, so if this is your metal, for the same metal, what you have is this. You have a metal which is same metal, but now the wavelength or of the photon that comes in is reduced to 3/4 lambda 0. And emission again happens, and therefore you have to find what is the kinetic energy of the photoelectron which is getting. So this is again an electron getting emitted. Okay, and I will just show a negative charge on this. You have to find KE2. Okay. Now, if you see this question very carefully, generally what you're given is a threshold frequency, but here what you're given is lambda naught. So instead of using frequency, they have given the wavelength of the photon, right? So you can obviously do conversion. And then you can see the wavelength has gone down, which means the frequency has gone up, okay? Which means the kinetic energy will go up because now more energy is available from the photons, and that some part of it in both the situations will get consumed in overcoming the work function. So let's write the equation for this and equation for this. So this is your total energy which is available to you. So energy which is available to you from this photon is h nu naught, but nu naught is not known to you. So let's use that C is equal to lambda nu, and lambda is equal to C upon nu is equal to, so you can write wavelength as speed of light divided by frequency. So this is h C upon, you want to write expression for frequency. So frequency is C upon lambda. So this is hc by lambda naught. This is the total energy which is available to you in this situation 1. And in the energy in the situation 2 which is available to you is hc by 3/4 lambda 0 is equal to 4/3 hc by lambda 0. Okay, so the energy has gone up. Now let's assume the work function of this metal is W. Okay, it remains same in both the situations. I told you metal does not change, the work function will not change. So therefore, if you use photoelectric effect equation given by Einstein, let's use that. Okay, now let's do mathematical modeling. Conceptually we are clear, the wavelength has gone down, the frequency has gone up, so more energy is available. So E2 is definitely greater than E1, and in both the situations emission has taken place. After overcoming the barrier of work function, the kinetic energy is available for electron, and we're dealing with maximum kinetic energy here. Okay, so this is also Ke2 maximum. Now the total energy which is available to you, E total from the photon, gets converted into the work function plus the kinetic energy. So this is work function of the metal. Many people write this as phi or whatever you want to write. Okay, so let me use situation number 1 and apply this. So this is hc by lambda naught, which is this expression, plus the work function is equal to kinetic energy 1. Situation number 2, hc by lambda naught plus w is equal to kinetic energy 2. Now as you can see, this is the only unknown, and therefore let's write this as 1 and 2, and we can either do substitution or we can straightaway subtract these two. What we get is, so let me just change this because this is 4 by 3. Okay, so this is bigger one, so I will do 2 minus 1, and this will become 4 by 3 hc by lambda naught plus w minus hc. So I'm writing the left hand side and subtracting the left hand sides is equal to the kinetic energy of the second side and minus the kinetic energy of the first side. So my work function gets cancelled, and what I get here is 1 by 3 hc by lambda naught, and I take this ke1 on the other side plus ke1 is equal to ke2. Okay, the question is, what is the increase in kinetic energy? If the increase in kinetic energy has to be found out, which is delta ke, when I say increase in kinetic energy, because the wavelength has gone down, the frequency went up, the kinetic energy of this electron went up because more energy is available, but only a certain amount of energy was used as work function. So if you subtract these two, what you get is the difference in kinetic energy between the photoelectron which is emitted here versus the photoelectron which is emitted here. And therefore what you get is 1 by 3 hc by lambda naught, right? So you would select this choice. The question was not, what is the kinetic energy, but the question is, what is the change in kinetic energy of the photoelectrons, right? So just by some, mathematical manipulation, which is solving the two equations, you're able to express what is the change in kinetic energy. So you can have many situations, many ways. Maybe the variable w was given and you were actually supposed to find kinetic energy. So you can have multiple situations. But I hope the essence of solving these equations, how to apply photoelectric effect is clear to you. In many situations, two metals are given. Okay, so this is metal number 1 and this becomes metal number 2, and we are expected to calculate some parameter out of these when we are drawing a comparison between metal 1 and metal 2. Either the same photon frequency is getting applied or different frequencies getting applied. Some ratio, some element, some parameter is to be asked. Very important topic, photoelectric effect. You can expect a numerical on this topic in NEET examination, JEE examination, and upcoming board examination. I conduct live classes, very concept oriented, very useful for those who want to build career in science stream and want to score very high in their board examination. Okay, so I really give you conceptual questions and material to develop your concepts. So join my live classes and see the magic of physics being made easy. Thank you very much. Good luck.